Okay, so in this lesson, we're going to talk about how we classify our data. So remember from last time, data is information that we're gathering from the world around us. So we've gone out, we've designed our study, we've collected our data. So now how do we sort that data? How do we figure out what type of data it is so that we know what we can do with it? So to start out at the most basic level, there are two types of data that we have. So we have qualitative data. This is data that consists of attributes, labels, non-numerical entries. The easiest way to think about qualitative data, think of this as words or as qualities that describe things. So these are words or qualities. To remember qualities, remember qualitative data starts with qualit. So qualities are words that are describing things. So attributes, labels, non-numerical entries. So some examples of types of qualitative data would be your major, your place of birth, your eye color, your gender, your hair color. Those are qualitative data. So these are just words that describe you. So for example, you're a nursing student, or you're an automotive student, or you're a culinary student, or you're a transfer student. So these are words that describe, in this case, you. And then the second type of data we have is quantitative data. So these are numerical measures or counts. These are quantities. So remember, easy way to remember this is quantities or numbers is that it starts with quant. So quantity, quantitative data. So some examples of quantitative data: age, weight of a letter, temperature, height. Those are all quantitative data. So let's look at a couple different variables. So in this example, I've got the base prices of several vehicles from the Ford Motor Company listed. And so we want to know, of these two variables that we have, which of these variables is qualitative data and which one is quantitative data. So if we look at this, so let's look at the two variables. So the first variable we have is model, and the second variable we have is suggested retail price. So if we look at the model, so what are the values of model? So we've got Focus Sedan, Fusion, Mustang, and so on down the list. So these are words that are describing the model of the car. So since these are words, these have to be qualitative. So the model is a qualitative data variable. Now let's look at the second variable we have, suggested retail price. So the different values it takes on are monetary values, so $15,995, $19,270, and so on down. So looking at that, these are numbers or quantities. So because they are quantities, this is a quantitative variable. So the next type of way we can start separating data out, the majority of our data is going to be quantitative. And so quantitative data, numbers, we can usually break that up a little bit more. So think of this as you're building a branch. So overall, you've got data. Data we can split into qualitative and quantitative. And then quantitative, we can split it into discrete data or continuous data. So the difference being quantitative data is discrete if you're counting something. So discrete data just means you are counting the objects. So discrete data is only going to be whole number values, or the counting numbers. So think of numbers like you could count on your fingers and toes, for example. That's going to be discrete data. So if you're counting something, so for example, maybe you're counting the number of red cars that you pass every day driving, or you're counting the number of cardinals that you see on campus on a daily basis. That would be discrete variables. Continuous variables, we're measuring objects. So because we're measuring, these are just going to be real numbers. So they might be a whole number, or they could take on decimal values or fractional values. So these can be fractions or decimals. So you can have parts of something here. So for example, your height, you might be 67.5 inches tall, for example. Or you might be 21.5 years old. So you can have parts of something. That's going to be continuous data. So let's look at some variables and see whether or not they are continuous or discrete. So the temperature in Fahrenheit of cities in South Carolina. So the easy way to ask ourselves whether something's continuous or discrete is to remember to ask yourself, am I measuring something or am I counting something? So identify your variable. In this case, our variable is temperatures. So temperatures is the variable. So do we measure temperatures or do we count temperatures? Typically, we are measuring temperature. So that if we're measuring, that's going to be a continuous variable. All right, let's look at the second one. So the numbers of houses in various neighborhoods in a city. So numbers of houses. So number of houses is our variable. And do we measure number of houses or are we counting number of houses? That's right, we typically are counting these. So that means it's discrete. Numbers of elliptical machines in every YMCA in your state. So same idea. Are we measuring the number of ellipticals or are we counting the number of ellipticals? So number of ellipticals is our variable. Typically we're counting these. We're not measuring. We can't have 2.5 ellipticals, for example. So we're counting. Therefore, this is also discrete. And the last one, heights of doors. So are we measuring the height of doors or are we counting the height of doors? So usually we are measuring the height of a door. You can have a door, for example, that is 72.1/8 inches tall. So because we're measuring, this is a continuous random variable. Now we can take this a step further and we can classify data in different levels. And so with these different levels, we're getting something extra. So really, you can think of these 4 different levels of measurement. Think of them as building up steps or going up a stairway. So every time you go up to the next level of measurement, you retain everything that you already had. So you're not going back down. You're not losing stuff. You're not going back down the staircase. You're still going up. So you keep everything that you already had. You have everything you've already gone through, but then you're adding something else every time. So if it's walking up a staircase, for example, you're adding elevation. But in this case, since we're talking about levels of measurement, we're adding another property every time we go up the staircase. So to start with, our most basic level of measurement we have is the nominal level of measurement. So data that is nominal is going to be qualitative data only. So nominal level of measurement, qualitative data only, so only words, only qualities. basically all we can do at the nominal level of measurement is categorize the data using names, labels, or qualities. That's it. So all nominal data can be used for is to categorize items, basically. So there's not a lot we can do with nominal. So nominal is our base level of our staircase. And all we can do with nominal is categorize our data, basically. So we can't do any mathematical computations with this because it is not numbers. It's not quantitative data. So because it's only qualitative, really all it helps us for is sorting, basically, or splitting data up into groups. So the next level we go up a step on our staircase. So we still have all the properties of the nominal data, but now we're adding in something. So we're still categorizing the data, but now at the ordinal level, now this can be qualitative or quantitative data. So we can have numbers or we can have words. And so the new piece that we're adding at this level, at the ordinal level of measurement, you have an order. So ordinal level has a logical order to it. So it makes sense to say something is first, second, or third, for example. So there's a logical order. So that's our second level, is ordinal. So ordinal level of measurement, you have a logical order. Now, something important to keep in mind. We don't yet have meaningful differences between data entries. So even though it makes sense to say something is first, second, third, fourth, so on, we don't know what's separating those values. So for example, if you think of rank of contestants in a beauty pageant, for example, then whoever wins first and second place might have been a really close call. So maybe one contestant dropped the plate they were spinning, for example. And that was the only thing that set them apart from the other contestant. Whereas there might have been a huge difference between the person who was in second place and third place, for example. So differences are not meaningful. We don't know what's separating each of these items that we're ranking or ordering. So we have a logical order, but we don't have meaningful differences between our data entries. So if we look at two different data sets here, and both of these happen to be qualitative variables. So we have two different data sets. We have the top 5 TV programs, and then we have network affiliates in Pittsburgh, PA. And we want to know, one of these data sets is nominal, one of these data sets is ordinal. Which is which? So let's start off looking at the top 5 TV programs. So we know American Idol was first, American Idol Wednesday night was second, Dancing with the Stars was third, NCIS was fourth, The Mentalist was fifth. So in this case, what we want to know, is this nominal or is this ordinal? So nominal, remember, we're just categorizing it. It's just words, basically. It doesn't tell us anything. Ordinal, we have that logical order. So if we look at this, do we have a logical order? We do. So top 5 TV programs, we can clearly say American Idol on Wednesday was the first. It was the top show. American Idol on Tuesday was the second most viewed show. So because we can say that, this top 5 TV programs is ordinal. Now let's look at the second data set. So the network affiliates in Pittsburgh, Pennsylvania. So we've got WTAE, which is an ABC station, WPXI, which is NBC, KDKA, which is CBS, and WPGH, which is Fox. And so we want to know, is this nominal or is this ordinal? So do we have anything that tells us we can put these stations in a logical order. So I will go ahead and tell you, alphabetical order in purpose of statistics is not a logical order. It doesn't matter if you have something alphabetized or not. So don't worry about alphabetic order. Is there anything mathematically that would let us put these stations in order just based on their name of stations? There's not anything that's going to let us order this data. So because we can't order it, this is just nominal data. It's just information. It's telling us, in this case, the names of these stations. So remember now, we've got the nominal level of measurement, which lets us put data into categories, but that's it. And it was only qualitative variables. Then we added in ordinal. So we still were putting data into categories. Now at ordinal, remember, it could be qualitative or quantitative. And we got that logical order, but we didn't have meaningful differences. So now we go up a step. So we still are putting data into categories. We still have a logical order. But now at the interval level of measurement, so we've taken out the qualitative variable. So interval level of measurement has to be quantitative. So it's quantitative data only. So no more numbers, no more words. The data now can be ordered. So now we still have that order. So remember, that's carrying through from the ordinal level of measurement. The difference between ordinal and interval level, now we have a meaningful difference. So we know the difference between 1 and 2 is the same as the distance between 2 and 3. Or the distance between 4 and 5 is the same as the distance between 10 and 11, for example. So now differences between our entries is meaningful. Now, be careful with that. When I say the differences between data entries is meaningful, I'm not saying every single data value that you have is only going to be 1 apart, for example, or 2 apart. What I'm saying is the units that you're measuring it in will have those defined differences. So it's what you're measuring it in that you have defined differences. And on this one, the interval level of measurement, 0 is just a position on the scale. So 0 can be a data value, but it's just a place on the scale. It's not an inherent 0. So in other words, the easy thing to ask yourself for this one, if you know that you have meaningful differences, is does 0 imply none or not? In this case, 0 does not imply none. 0 is just a location on the scale. So, for example, if I'm talking about the temperature in Pinehurst on any given day, measured in degrees Fahrenheit, then we know it could be 0 degrees Fahrenheit outside, right? It doesn't happen often in Pinehurst, but it can happen. We can have a 0 degree day. So if we have a 0 degree Fahrenheit day, we're not saying we have no temperature, right? What we're saying is it's just a position on that Fahrenheit scale. So 0 does not imply none. 0 degrees Fahrenheit does not mean no temperature, for example. Now our last level of measurement, so remember we've got nominal, that was just putting data into categories, just words. Then we added in the ordinal level, so we got that logical order. And then interval level, we had that defined difference between data values. And so now our topmost level that we have is the ratio level of measurement. So ratio and interval are very, very similar to each other. So you still are putting data into categories. You still have that logical order. You still have meaningful differences between your data values. The difference between interval and ratio is what 0 means. So remember, with the interval level of measurement, 0 is just a position on the scale. With the ratio level of measurement, 0 means none. 0 is an inherent 0. So 0 means none on the ratio level of measurement. And this lets us form a ratio of two data values and express one as a multiple of another. So let's look at a couple of data sets. So we've got New York Yankees World Series victory, the year that the New York Yankees won the World Series. So these two data sets are either going to be interval or ratio. So you don't have to worry about nominal or ordinal right now. So either interval or ratio. So if we're looking at New York Yankees World Series victories, the years that the New York Yankees won the World Series in. So we know that we have order. We know that we have meaningful differences because we're at least at interval ratio. So the big question we need to ask ourselves to know if this is interval or ratio levels is, what does 0 mean? So what does the year, in this case, so we know we're measuring in years, what does the year 0 on our calendar mean? So when we say the year 0, because that's potentially the earliest year that the New York Yankees could have won a World Series in some ways, right? No, because think about it. The way we measure time, so a little bit of a lesson in how we measure time. So we've got the AD scale, or sorry, BCE scale. So we have BCE and CE. Everything we're in now, we're in CE. We're in what we call the Common Era. And then we have the years in BCE, which are before the Common Era. So the year 0 CE, or what we used to say 0 AD, that's just essentially when we began the Common Era. But there was still years before that. So we still have all that time that was in before the Common Era, what we used to call BC when we used to say BC and AD. Now we say BCE and CE. So everything that's in before the Common Era is still time that's existing. So 0 CE is not mean none. So it's just a point on our year scale. Now, of course, we know the Yankees haven't been around since 0 Common Era because Major League Baseball hasn't been around that long, right? But the idea is, think about what you're measuring in. In this case, we're measuring in years. So actual physical years. And so we know we could potentially have the year 0 Common Era. So because 0 in this case does not mean none, it's just a place on the scale, then that means New York Yankees World Series victory has to be the interval level of measurement. Now let's look at our second data set. So we have 2009 American League home run totals. And so we want to ask ourselves the same question. What does 0 mean? So if a team, in this case, we're measuring home run totals. So what does it mean if a team hits 0 home runs? Well, if they hit 0 home runs, aside from meaning they're a horrible baseball team, it means they did not hit any home runs, right? They hit no home runs. So here, 0 means none, right? So that means that the home run totals are at the ratio level of measurement. So just to summarize those 4 levels of measurement again. So same picture I drew, just upside down. So nominal, ordinal, interval, and ratio. All 4 of these variables can put data into categories. All four of these levels of measurement put data into categories. We go over to arranging data in order. Nominal cannot do this. Nominal does not have an order. Everything else does. Then can we subtract data values? So in other words, do we have that defined difference between two data values or two possible data values? So in this case, interval and ratio levels, we can. Nominal and ordinal, we do not. And then can we determine if a value is a multiple of another? The only one that we can do that in is the ratio level of measurement.